We're going to be looking at a design pattern this week, and it's going to be the composite design pattern. And actually, this is just about the first design pattern I ever formally came across. And this was a long time ago, back in the 1990s, really at just about the time that the famous book Design Patterns by the Gang of Four was just being published. And I wasn't really aware of them, and something happened to me that I'm sure has happened to lots of people. I did quite a complicated design, spent a lot of time on it, and then a colleague came and had a look at it and said, "Ooh, that's the composite pattern." And that was my introduction to that pattern particularly, and the Gang of Four book and patterns in general. Composite is actually related to a number of other patterns, particularly a couple called the visitor pattern and the flyweight pattern, and we'll be looking at those in later videos. But for now, let's concentrate on this composite pattern. And so what we've just got here is a simple application that is putting together some kind of to-do list. And so what I've got is this to-do item, and a to-do item has a constructor that sets up the four properties: name, description, hours, and cost. And then all we've put on there is just a toString that doesn't bother with the description, but just gives us the name, the hours, and the cost. And just to save a bit of time, I've also put together these sample items. So we've got design GUI, so that has the name of design GUI, it has a description, it has an hours, and then we calculate the cost as a fixed pay rate times the number of hours. We have a similar thing for program the GUI, and then we're making a phone call. So in that case, it's the duration times the call cost. We buy a cup of coffee, that doesn't take any time but has a fixed cost. And so we've got a number of those. And then in my main program, I simply have this list of to-do items, and then we just add each one of these sample items to the list. And then having done that, we could have some way of maybe looping through them. So I could say for each var item in items, and then we could just do a console write of the item. And if we run that, we can see we just get them all listed there. And we could do other things, like we could do a console write of total cost is, and then items dot sum I gives I dot cost. Format that as currency. And similarly, we could do one for the time. And so if we run that up, we can see we're getting that total cost and that total duration. And those numbers will come in handy later on, because they'll just allow us to check that when we change the structure of this, we're still getting the same results. Because the first problem we'll see here, and it's not really directly related to the composite pattern yet, it's just general inheritance, is that we've actually got really three distinct types of to-do items. So if we look at those sample to-do items, you can see there is one where we do some work, and that will always have a cost of pay rate times the number of hours. So we've got some of those. We've got communication, which is always going to have the call rate times the number of hours. And then we've also got the purchase, which is always going to have 0 hours and a fixed cost. And so what we can do, in fact, is introduce derived classes to do each of those things. So we've got a work item, which only takes name, description, and hours, and then calculates the cost on the hours times the pay rate. We have a purchase item that simply takes the cost and always sets the hours to 0. And we have a communication item which only takes the hours and multiplies it by the call rate. So that's simplified things a little bit in terms of each one of these derived classes knowing the rules of how it should behave. What we would then do is go to our to-do item, the base class, and we can make that abstract. So now you can't actually have a to-do item, you can only have the derived classes. Which of course means that my sample items are now not working. So we'll remove these items and then introduce these other items which use the derived classes. And so we can see here that we've still got the design GUI, but design GUI is now a work item. We've still got call New York, but call New York is now a communication item. We've still got buy coffee, but buy coffee is now a purchase item. And so the program works in exactly the same way. And although we're adding these different items, they're operating through a base class, so it's still just a list of to-do items. So not actually the composite yet, just typical use of polymorphism and inheritance, and that should behave in exactly the same way. But then the thing we want to think about is how we group these things together, because we're just putting them together into a list, but why not have some sort of class to actually group together these individual to-do items? And that is really the first step towards the composite, because what I'll do is I will, in here, let's add a new class, and I'm going to call this composite item. And then on that class, that is where I will have my list of items. So let's pop that in as a private member. And then what I'm also going to do is give that an add method. So let's have a public void add, which is going to take a to-do item and then simply add it to that list of items. And then we're also going to have a toString. So we'll have override of toString. And all that's going to need to do is it's going to loop through and call the toStrings on the other items. So we'll have a string builder, and then we'll simply loop through and just do an append line on the item.toString. And then return the overall thing. And then a couple of other things we need. Remember, in our program, we were calculating the total cost and we were calculating the total duration. So we can actually grab those as well. We're going to have a public decimal cost, which is simply going to give us that same calculation. And then we're going to have another one for hours. So that's going to be a double called hours that returns the number of hours. And then having done that, it's actually pretty simple to replace that in here. So let's just call this our composite. Because we had a method called add, it's the same as for the list, so we don't need to change anything there. And then here, we can just do a console.writeLine of the whole thing, because it's got a toString, which looped through. And then also here, we can just say items.cost and items.hours to use those other two properties that I put in there. And when we run that up, we get the same result. And remember, look at those totals, they're the same, so we know that that's working. And so that's the first part of our step towards a composite. But what we'd then really like to do, and this is what properly makes this the composite pattern, is we would like to not just have one big group of items of different types, but we would like to structure that hierarchically so that we can have subgroups and subgroups within subgroups and so on and so forth. And that is done very, very simply, because all we have to do is, firstly, on our composite item, we make composite item itself derived from the base class to-do item. And when we do that, you'll see it's got a couple of objections. Firstly, we need the constructor. So let's, in here, pop in a constructor. And the constructor for the composite item is simply going to need a name and a description, because the hours and the cost are made up of the child component. So here, we'll just put in string name, string description, and then pass those down to the base class constructor, and then 0 and 0 for our hours and our cost. And then the other thing you'll notice is that by putting in cost and hours, we are currently hiding what was in the base class. So we need in the base class to make those two virtual, and then also to make those two override. And then we just need to pass those into the composite item back in the program. So here we've now got to say develop site as the name, and then let's have all the work for developing my website. And then everything should behave in the same way. So when we build that, we see we get exactly the same results. And then what we can see there is, because this composite item has a list of to-do items, and composite item is itself a to-do item, then a composite item can contain other composite items which can contain other composite items. And so we make a distinction here of what are known as leaf nodes, which are things like our work item, our purchase item, and our communication item, which don't have any children, and then composite nodes, which can have children, which are either leaf nodes or other composite nodes. And that is the basic idea of the composite pattern. So we get this structure, which in general terms, if you look at the diagram in the Gang of Four book or something like that, we have a base class called component, derived from that a number of what we call leaf nodes, and then also derived the composite node, which has the collection of other components. And then if we switch that to what we've got here, our component is the to-do item, our leaf nodes are purchase item, work item, communication item, and our composite we've just called composite. And that's normally a good idea because that gives everyone a clue that that is the pattern that we're using. But it means now we can have this arbitrary depth of hierarchy. So what we can now do is break this down into smaller subcomponents. So let's copy that. And we're going to have dev client side. So this is going to be develop client, all the work for developing the front end. And then we'll have another one that we'll call dev server side and call that develop server, and then change that to the back end. And then we add both of those to the main project, and then the individual items we can assign into different subprojects. So let's put the first 4 of them into the client-side development, and then the remaining ones into the server-side development. And if we run that, we should see it still working in exactly the same way. Something now we can additionally do, though, is if we go back to our composite, we could actually put a main title on there. So before we print out the individual items, we could just do an append line of our own name. And so now when we run it, we can see we've got the develop site, and then develop client, develop server, and so on and so forth. Thing to notice that's very important here is our cost and our duration are still the same results, even though now we've got this more structured approach. And that works still because if you think about how cost and hours work on the composite, they simply add up the cost and hours of all the children. And even if those children are themselves composites, they will just add up the cost and hours of their children, and so eventually we get exactly the same result. So it's no longer a flat addition of the cost or the hours, it's a hierarchical one, but it still adds up every one of them. Something else we might like to do there, if you look at the structure, it's a bit messy now in that it's all lined up on the left-hand side of the page. We can't really see the structure. It might be nice if we could do some indentation. That's where things actually get a little bit tricky, because you might think, well, the simple thing to do is let's just put in here 4 spaces of indent just before we print the children. But the problem you can see there is now we've got this quite deep hierarchy. That worked okay for the first level, but then just everything else is the same. So actually we have to do something a bit more sneaky here. And what we do is we go to the component, the to-do item, and on here we actually overload toString. And we put in an int that we're going to call indent. And this is no longer an override because that's not the one in the object base class. So actually we're going to make this virtual. And we'll also default that to 0 because we don't need any indent to start off with. That then will have to also appear in our composite. So our composite now takes this indent in the same way. But now that we've got that, we can do the clever stuff, because what we can do is here, rather than indent 4 spaces, we can indent 4 spaces multiplied by the indent. So I can actually do that with a handy string constructor. That has a constructor that allows me to specify a character followed by the count. So here I'm going to say indent times 4. But what I also have to do is pass the indent down to the child item, so it will do the same thing. But also, each time we move down a level, I'm going to need to increment that. So I'm also going to here say plus plus indent. Just one other thing we have to do, that right line is going to implicitly call the standard toString, so we've got to make sure we call that new toString that we've put in there for ourselves. And so now we can see that develop site has children, develop client, develop server, and they've got those individual children. And that will now work. We could go even further than that. So let's actually notice what was happening here. Let's split that up and have another composite that we'll call initial develop server side. And then a second one called retry and call that second. And then both of those are children of dev server side. So take that, call that dev server side, and then pass in the two phases of it. And then once again, break this down. So those first three tasks are part of the initial phase, and those second three tasks are part of the final phase. And so now when we see it, we get an even more segregated hierarchy where each one has its children. We can really see that broken down. And if we look at the structure of that, we can see that just diagrammatically, develop site with 2 children, develop client just has leaf node childs, develop server has more composite children, and then those have got the leaf nodes underneath that. What we could also do is, you don't have to have it quite as strict as that, so at the very end we could just maybe in here, right back on the overall project, we could just add a leaf node directly. So it doesn't have to be that if one child is a composite, they all are. We could just put in here, have a new purchase item, and let's call this champagne, and then give it a description, and then just a cost. And now if we put that in there, we can see we get just that leaf node directly as the child of develop site. The nice thing about this, and the key feature of the composite pattern, is whatever you're looking at, whether you're looking at a composite or if you're looking at an individual item, regardless of its type, they still have the same interface. We can still manipulate everything through that to-do item base class, the component. And we can show quite a good way to exploit that if we put in something like a find. So what I'm going to do is, on the base class, let's now have a public virtual to-do item. So it's returning a do item, and it's called find. So obviously what it finds could be any one of the derived types, but we can just return it through that to-do item base class. And then what I'm going to do is have a string that we'll call name. And then on the base class, simply enough, all we need to do is say we're going to return. And then if the name passed in equals our own name, then we're going to return ourselves. Otherwise, we're going to return null. So that's what we've got on the base class. And then if we go to the composite, then we can also override that. And so in here, we'll say override of find. But in this case, things are going to get slightly more difficult. The first thing we've got to do is we've got to check whether the composite itself, which has a name, remember, matches up. And so what we're going to do there is say var found equals, and then just call that find on the base class, which is checking that the name matches ourselves. Obviously, if that's correct, so if found is not null, then that's what we return. But otherwise, we need to check our descendants. So what we now do is we loop through, we say for each var item in items, and then we say found equals item dot find matching the name passed in. And then we say if we've found it, so if found does not equal null, then we return what we found. And obviously we don't loop any further. Whereas if we get right off the end of that and we don't find anything, then it's not been a match within this composite, maybe in another composite, so we simply return null at that point. So, fairly simple structure, but again, following the basic pattern that we always have with a composite, that any method in the composite that we override from the base class basically has the job of simply looping through all of the children and calling the same method, maybe with a bit of additional work. So here we can see the toString simply loops through and basically calls toString in each child with a bit of additional work, in this case of indentation and putting on our own name. The cost and the hours, it's done very simply in terms of C# code, but that is looping through and calling cost and hours on the children. And the find, again, a bit of complexity, but basically looping through and delegating to the children. But what that means is now in our program that another thing we could do right at the end of all this, we could say something like var found equals, and then we're just going to say items, so right up to the root dot find. And then if we look for our, let's look at, say, the retry server side. So remember that had a name of develop server second try. So if I pop that in there, and then we'll just do a console write of found. And of course it might be null, so we'll do a quick safety check on that. So we'll either do the toString or we'll just say not found. And then if we run that, we can see that there is the develop second try that we looked for and tried to find it. If I misspell it, then we just get not found at the end. Or if I just search for an individual item, we don't care whether we're getting back a composite or an individual item, because this type of found, let's put it in explicitly, is always just going to be the base class to do item. So there we've got the new server that we've found. So that's the composite pattern. The idea that we have a base class, to do item in our case, from which we derive a number of leaf nodes like purchase item and work item, but then also we have the composite derived from to do item, but when the composite overrides the methods in to do item, its job is always to loop through the children and delegate down to call the methods on the children, and if those children are composites, it just gets all the way through. There's lots and lots of circumstances where that's used. That example I was giving you right back at the beginning of where I first saw it was in a graphics application where you wanted to be able to have an overall picture with subcomponents that you could break down to an arbitrary depth however far you want to go. In this example, we've also got that arbitrary depth. You will find situations where actually the depth of what you want is not arbitrary. There is something more fixed to it. For example, I was using this recently in television programs. So there you have a composite, but it's just got 3 levels of depth. You've got a program, which is subdivided into series, which is subdivided into episodes. Now you could argue, well, we could just have a separate class for those 3 layers. And when it's as simple as that, it might work. But generally it's easier just to have one class and add some artificial limitation that the depth can only be 3. Another example might be something like an army, where with an army you have the idea of a force, and a force is broken down into commands. Command is broken down into divisions, divisions into brigades, or something like that. And again, although you could make a separate class for each one of those, much simpler just to have those all as composites, give them the appropriate name, such as division and brigade, and save yourself writing lots and lots of classes. That said, there are some limitations on the composite pattern, and one of the ones you might notice is the more methods you add to your base class, to do item in our case, the more work you have to do, because you've got to override that in each of the leaf nodes and in the composite node. And if you find yourself doing that, then you want to use another pattern in addition to the composite, which is what we're going to be looking at next time, which is the visitor pattern. But for now, that's the composite pattern. If you enjoyed that, do click the like button, do subscribe, and come back next time to talk about the visitor pattern.